Hi, my name is Darina, and we are going today to solve a problem about transforming functions and exactly about translations. Y is f of x plus b and y is f of x minus a. So, we have a problem. For functions f of x equals x squared and f of x equals e powered by x and f of x equals 1 divided by x. And for those three functions, we have to sketch on the same set of axes the graphs of y equals f of x, y equals f of x minus 2 plus 3, and y equals f of x plus 1 minus 4. Okay, let's do it. Let us see first what does those translations mean. Okay, translation y equals f of x plus b. If we have some graph f of x, then when you are adding this b, you are sliding the graph vertically for b units. If b is positive, we are sliding up. If b is negative, we are sliding down. So we can say that b translates the graph vertically through b units, and if b is positive, we are going upwards. If b is negative, we are going downwards. Okay, then the next translation is y equals f of x minus a. So we see that a is number. It shows how x is changed, the argument is changed, and we took it into the brackets. So if we have such a translation, it means that graph is sliding right or left. And if we are adding some number to x, so if a is negative, we are sliding left. So everything is opposite. And if we are subtracting some number from x, so a is like positive, we are moving to the right. So we can write a translates the graph horizontally through a units, and if a is positive, so we're subtracting some number, we are going right, and if a is negative, we are going left. Okay, and the last translation is when we have combination of vertical and horizontal sliding. So if we have the function y equals f of x minus a plus b, so we changing x and we are editing some number to all the function. So we have sliding horizontal and we have sliding vertical, and we can write that our graph is translated by vector ab horizontally through a units, and you see if we are adding the number, graph will be translated to the left, and if we are subtracting some number, graph will be slide to right, and vertically through b units. If we are adding some number, it goes up, subtracting goes down. So let's see how does it work by solving our problem. So we have function f of x equals x squared. It's our parabola, and we can sketch it easily, and we have two more functions. This is the first one, y equals f of x minus 2 plus 3. So argument is changed by subtracting 2 units, and to all the function we added 3. And this is the third function, y equals f of x plus 1 minus 4. So let's do all those three graphs on one set of axes. Okay, this is our function f of x equals x squared, and we moved it, slided it to the right for 2 units because we have changing of our argument like subtracting 2, so we moved right, and to all the function we added 3, so we moved up for 3 units. So you see, I just took some main points like that and found this point minus 1 1 moved to point 1 4, 1 1 moved to 3 4, minus 2 4 moved to 0 7, and 2 4 moved to 4 7 and sketched our next graph. Okay, and this is the third graph. We moved left because we're editing 1 for 1 unit, and we slide it down for 4 units. So 0, 0 becomes -1, -4, and -1, 1 became -2, -3, and 1, 1 became 0, -3, and so on. Those 2 points and sketch. Okay, this is with the first function, and let's see another one. F of x equals e powered by x, and to our translations. Okay, let's see e powered by x. Okay, this is our f of x equals e powered by x. You see, when x is 0, we have 1, and when it's 1, it's e, and this is our horizontal asymptote. X-axis is our horizontal asymptote. Okay, now let's see, we have to move it right for 2 points because we're subtracting 2 from x. Okay, 0, 1 became 2, 1, but we have to slide it up for 3, so 0, 1 became 2, 4. Yes, this is our point, and x equals 3 will be our horizontal asymptote, and I just found few more points to be easier to sketch it, like 1 that was e became 3, and e plus 3, it's like 571 almost. So, and we sketched it. So this is asymptote. Okay, and let us see the third graph. Okay, this is our third graph. So we moved our first graph, we slided it to the left because we added 1, so we have to slide it 1 point left, and we slided it 4 points down because we have -4 here. So point 0, 1 will be -1, -3, and we'll have horizontal asymptote, and everything the same. F of x equals 1 divided by x, and those are our 2 functions. So let's see, this is our function f of x equals 1 divided by x. Some more important points like 1, 1, -1, -1, 0.5, 2, 2, 0.5, and so on. Our asymptotes, our axes are our asymptotes. And now we have to move, to slide our graph 2 points right, because we're subtracting here. In the brackets is x minus 2, 2 plus 3, because we're sliding everything up 3 points. It will be like new origin here, 2, 3, and point 1, 1 became point 3, 4. This is point 2.5, 5, and so on. And the same with this half of our graph. This is point 1.5, 1. This is point 1, 2. It was here before. And this is point 0, 2.5, because it was -2 minus 0.5. And this is horizontal asymptote, y equals 3, and this is our vertical asymptote, x equals 2. Okay, and that's it. Let's see our third function. What we did, it was our function f of x. We slide it 1 unit left and 4 units down. So this is our new origin here. It will be -1, -4, and 2 parts of our graph. One is passing through 0, -3, like it was 1, 1, and -0.5, -2, like it was 0.5, 2. Here before, it became here, and this point was 2, 0.5, now it is 1 minus 3.5. Okay, and this aisle is the same. I just found those points, those more important points. This is minus 2, minus 5, because it was minus 1, and became minus 2, minus 5. And minus 2 minus 0.5 became minus 3, minus 4.5. And this is our horizontal asymptote, y equals minus 4. And this is our vertical asymptote, x equals minus 1. So that's it. We did it. Thank you for staying with me and hope to see you soon. Bye!